Good morning, class. I'm going to demonstrate what we're going to be doing in our membrane transport lab this afternoon. So the first thing we're going to do is we're going to open up a web browser. We're going to go to commonsense.org. We're going to go over here where it says We Educate, and then over here, the second tab over, Apps and Websites for Learning. Click on there. This Common Sense Education website has a bunch of fun, interactive things to do for all subjects, not just science. There's lots of things to play around with here and look around. For example, this homepage has a bunch of AI tools. So for our lab, what we're going to do is we're going to just filter some things out. We'll go to 10th grade and we're going to open up subjects. We're going to go to biology. And the first thing on the list is PhET interactive simulations. This is what we're going to be using in lab. So we're going to open that up. We're going to click Get It Now. Now this PhET website, it has a bunch of fun interactive tools across all of these science disciplines. You can get on here and play around, and it's very helpful for teaching different science concepts. What we're going to use is the membrane transport is over here in biology. And we're going to open up membrane transport. During lab, we're going to be simulating a bunch of different membrane transport simulations, simple diffusion, facilitated diffusion, active transport, and so on. I'm going to demonstrate one. And so this one's going to be an active transport. So we're going to simulate a sodium potassium pump. So let's put a bunch of sodium outside the cell because we know that sodium has a high concentration gradient on the outside of the cell. And we know that potassium has a high concentration gradient inside the cell when it's at its resting membrane potential. So this is a cell that's just depolarized. So we're going to have some sodiums in here, and we're going to have some potassium outside the cell. And so we're trying to fix this concentration gradient. So the first thing we need is a transmembrane protein. And so you can see already this sodium is bound to this transmembrane protein because it wants back out of the cell where it belongs. The problem is it is trying to go across the concentration gradient. That means we're missing something. We need energy. So we're going to come over here to ATP and we're going to throw some ATP in here. And there you go. We bound ATP and we are moving solutes across the concentration gradient. So what we're going to do with our lab is we're going to wait for each stage of this process to occur. So the first step is we're going to wait for these sodiums to bind to the protein on the inside of the cell. It'll cause a conformational change and cause this protein to open and allow the sodium out. So we'll pause it here. And then what we're going to do is we're going to hit print screen. Now on my computer, I've got a plus sign, which you will too, but you can't see it when I'm on my ScreenPal screen sharing app. So it just shows a yellow circle, but you'll have a plus sign there. Move the plus sign over to the top left corner. Press and hold your left mouse button, and you're going to just drag it over and highlight what you want to copy. And so that's going to copy to your clipboard. So there it is right there. It'll pop up. It'll copy to your clipboard. So then we're going to go over here to a Google web browser. We're going to go over here to our waffle and we're going to open up Google Drive. I'm already signed in, so it'll just open my Google Drive. And I'm going to go over here to New and New Google Slide. And so now what I'm going to do is I'm just going to right click and paste, and we're going to get a new slide. We're going to go back and we're going to play, and we're going to show that ATP binding, and we're going to show that conformational change, and same thing. We're going to print screen and go through that same process. And so I'm not going to do this again, but that's how we're going to do this. And we're going to do this for each step in the membrane transport simulation that we're doing at the time. And then what we're going to do is we're going to write a short explanation of each one of the processes, and we will draw these illustrations.